as a small bonus, right, I wanted to highlight the connection between v squared equals u squared plus 2as with the work energy theorem. So the work energy theorem is something that we'll cover when we talk about dynamics, Newtonian mechanics, right, in the next chapter. But roughly speaking, if I'm given the differential equation, sorry, we haven't talked about differential equations, but if I'm given the expression, if I'm given this definition, right, a is the second derivative of s. If you do know a as a function of time, then the way to get s is just to integrate with respect to t twice. So you integrate with respect to t, and then integrate with respect to t, and then you get s as a function of t is equals to second double integral. Let's write it like that, right? We'll do the first integral first. However, sometimes in physics, right, we are not so fortunate and we do not know a as a function of time. And instead, we actually know a as a function of, let's say, position. So that will give rise to a very interesting scenario where a is not a function of time, but a is a function of position. And of course, position is a function of time, but it's kind of like if a is only given as a function of position, then if we try to integrate twice, right, we do not know a as a function of time, so we can't really integrate it. And this cyclic dependency where in order to find s, we need to integrate a twice, but in order to find a, we need to know s. We're kind of stuck in a loop where we were unable to find one quantity without finding the other first. And in order to solve this would require the technology of differential equations for full generality, right? We need to solve this differential equation when you find s such that it's self-consistent. However, we will talk about this in the, I think, 2 chapters down the line, but sometimes, for now, right, there is an interesting observation, and the observation is that if we do not integrate with respect to time, but instead we integrate with respect to position, right? So if we integrate both sides of this equation with respect to ds, right? So integrate it with respect to s instead of t, right? So we write ds instead of dt. Then we can actually obtain something like v squared equals u squared plus 2as. In fact, that's exactly what we get, right? We get v squared equals u squared plus 2as. And integrating with respect to s is the same kind of procedure we're doing when we derive the work energy theorem. So in some sense, this is just the kinematics version when we integrate with respect to ds, and work energy theorem is kind of like the dynamics version when we integrate with respect to ds. But at the core, right, both of the math is the same set of steps, right? You're doing the same kind of math in terms of you're doing the exactly same math. It's just that the physics interpretation, one is in terms of kinematics and one is in terms of dynamics.